Alright, so for this video we're going to be talking about system of equations and inequalities. Basically we're going to be looking at, in equations we're going to be looking at where they intersect, and then for inequalities we're going to be looking at the overlapping area because we're going to be looking at shading. So just to kind of start out looking at the first system, we have y equals 2x squared plus 1 and y equals 2x plus 3. Now this is a system of equations because of the fact that they both have equals. So we're looking for the intersections. We're looking at the points where they intersect each other, and we're looking for those points because of the fact that where they intersect are where they are equal. Alright, so if I graph these, you can, I have the graphs already on the notes, but if I put them in Desmos, I can click and I can see exactly where they intersect each other. So this particular problem has two solutions, and those two solutions are going to be negative 1, 3 and 2, 9. Okay, so when you're doing equations, you're always looking for the intersections, and they may not intersect at all, which means they would be no solution. So when we look at inequalities, we're looking at greater than, less than, greater than or equal to, less than or equal to. So for the first one, we're looking at greater than, and it's got no equal to sign. And then we're looking at greater than and no equal to sign. So if I change my shade or change my inequality sign here, you can see that I now have shading that is going to happen. So let's turn this one off for a second. So we're looking at the parabola, which is the quadratic. If we're looking at greater than, first thing that we need to look at is the fact that these are going to be dashed lines. So these are going to be dashed because the lines themselves are, the graphs themselves, the border lines of them are not going to be included. But every point in that area, in the shaded region, okay, is going to be included here. So we're looking at this shaded area here and anything that goes above that. So you can see that as long as I keep scrolling, anything above in that area. Alright, so then I'm going to look at the line. So the line is also going to be a dashed line because of the fact that it's not equal to. So this is going to be dashed, which means that anything on that border is not included. And then any of my shading here is going to be above it because it's greater than. Okay, so really where I'm focusing, my solution region right here is going to be where it overlaps. It can't just be the green. It can't just be the orange. It's got to be where they overlap. However, these intersections right here are not included because they're on a dashed line. So dashed lines mean that they are not included. The only points that we can include here are going to be where it overlaps. So any point that falls into these areas are considered solutions. Anything that falls in just the green is not going to work. Anything that falls in just the orange is not going to work, or any other area. Alright, so now we're going to come and we're going to do less than. So how do I have less than here? And less than. So I can just change these right quick. And this is going to become less than, which doesn't change the shape, it just changes the direction in which you're shading. So this is still going to be a dashed line, which means any point that falls on that dashed line is not included. But this time the shading is going to occur below the quadratic. So it's going to occur everything outside of the quadratic, but not inside it because it's less than. Alright, and then with our line, again, it's going to be a dashed line, but it's going to be less than the line, so it's going to be below it. So anything below that line is going to be included. All right, so we're looking for where it overlaps. So remember, the overlap is the solution region. So that's going to be the solution region in there. Any point that falls in that solution region will work for both inequalities. All right, so then we have an alternate of greater than, less than. So that doesn't really change much. It's still going to, I mean, yes, it's going to be, one's going to be greater than, one's going to be less than. But it's just going to change where the solution region is based off of where the shading is. So we're looking at the x squared. So this is going to be our dash line. And in that dash line, we're going to be looking at greater than. So our greater than, since it's going to be above it, is going to be shaded above it. So it's going to be inside of it. All right, and then for the other one, again, it's going to be a dash line because it's not equal to. And then it's going to have shading below it because it's less than, so we're shading this way. All right, so this one has a smaller solution region. It's only going to be in this little area right here where it's overlapping. And again, if there's a dash line, it doesn't include any point on the dash line. All right, and for the last one, we still have our dash lines because there's no equal to, which we will see some in the examples in a little bit. And right here we have less than, so that's going to change to less than. And then the other one is going to change to greater than. So again, the shading just changes where the direction of the shading is happening. So because of this, the less than for the quadratic is going to be below. Once again, it's below it because it's less than the quadratic. All right, and then we have our greater than for the line. So greater than is going to be above the line. So it's going to include anything above that dash line. So our solution region is going to be where it overlaps again. So you can see that the overlapping is not just going to be the orange, not just going to be the yellow. It's going to be where they overlap one another. Okay, so again, the key is where do the two overlap each other? And you should also be able to see, it's kind of hard, you can see it more on Desmos, but this right here, because of the way it extends, this is going to wind up being a solution region over here as well. Right here is going to start. So you can see that they're including both areas where it's overlapping. All right, so we're going to go ahead and look at the examples, and we're going to talk about systems of equations and then inequalities. So if we're looking at a system of equation, remember you're looking for the exact point where they intersect each other. So we have a linear system of equation first. So if I graph that in Desmos, I should be able to see that the solution there is going to be 4 and 4. Okay, so we're looking for the intersection because it's an equation. All right, so for this one, I have y equals, and I have the square root of x minus 4, and then I have y equals, parentheses, x minus 6 and squared. So this one has two solutions, okay? I do not care where they intersect the axes, I care where they intersect each other. So this one has two solutions, so we're going to say 5, 1, and then we're going to say approximately 7.4 and 1.8. So this one has 2 solutions. All right, and then for the next one, we have y equals 1/4 x plus 0.5, and then y equals negative 2x minus 4. So we're looking for where it intersects, and it intersects at negative 2 and 0. All right, so then we have a quadratic, so y equals x squared minus x minus 6, and then y equals 2x minus 2. This one has 2 solutions. It intersects twice, so it intersects at negative 1, negative 4, and then at 4, 6. All right, so then we come to inequalities, which, again, inequalities are where they're overlapping. So right now we have an equal to, so that means that we do have a possibility of having a boundary that we can use as a point. All right, so then we have x is less than or equal to negative 3. All right, so we're basically looking for the overlapping area. So if you look at my graph, we're not looking for just the blue, we're not looking for just the red. We're looking for where they overlap. So basically, I can provide one point that falls in that overlap. Now, I can include the intersection. The intersection will work because they're both equal to. So that is a possibility. But any other point that falls in that region. So like if I pick negative 4, negative 8. That'll work. Any point that falls in that overlap. All right, so we got to make sure we find the overlap of all of these. So we're looking at, let's see, we're looking at the overlap for the purple, the red, so it's really going to fall right here in that area. So like, let's see, so we could say 1, 4. Oh, nope, 1, 4 is going to be on the dash line. That's not going to work. So 1, 3. So we could say 1, 3. We could say 2, 3. We could say any point that falls in that overlapping area. All right, so then we have this one. Again, this one's a little bit different looking. It does have a circle, but that's okay. We're still looking for the overlap. So anything that falls in that overlapping area. Very simply, I could even say the intersections, because the intersections are both solid lines. Those would work. As long as they are solid, the intersections will work, but anything in the overlapping area is also going to work. So I could pick the point 10, negative 10, and that would be a solution. All right, so again, here I could pick another point that's in that upper region up there. So I could say 0, 10. I could do anything that's in that overlap. Anything. All this stuff up here in this overlap is a solution to that. So this one wants us to basically test if that point is going to be a solution. So we're looking at the absolute value of x plus 5, and then y is less than or equal to 2. So, this one's going to be quite small in the overlap. So that overlap area is the only one that'll work. So they want us to test 2, 0, 2. So that does not work because that only falls on the green, not in both of them. They have negative 1 and 6, and that only falls in the blue, so neither one work. Okay, and these points right here would not be solutions either. Why? Because one is solid and one is dashed, so it's not going to include a solution for both of them. All right, and then we have x is greater than negative 1, and then we have x is less than or equal to 1. And then we have y is greater than or equal to negative x squared plus 6. So we got lots going on here, but this overlapping area is like that middle section. So they want us to test 0, 0. So 0, 0 is a solution because it falls in the overlap. Okay, so anything in that overlap, but it couldn't include a point there because that's on a dashed line. That one, this point could be included because they're both solid. Okay, so it's just all about if I have a dashed line versus a solid line. So dashed lines are not included, solid lines are.